Hello everyone. Today I will present applying decision tree to detect credit card fraud. We come from Zhonghua University Information Management Department in Taiwan. Decision tree was first proposed by Hunt in 1996. It is a model that uses the concept of tree branch as a decision mode. Most of it can be used in classification prediction. It is divided into the following three types: classification tree, regression tree, and a classification regression tree. The classification tree is used to predict the training string number of the category type. The regression tree uses regression analysis to predict the value, and the classification and the regression. We call that a CART, C-A-R-T, was developed by American statistician Leo Bremen in 1984. It is proposed that it combines the characteristics of classification tree and the regression tree, which can predict the type of classification and also predict the numerical data. The feature is that only two branches are generated for each classification, which is used to plan and analyze the data set, and it is not limited. Variable types have greater flexibilities in analysis. Establishment of the decision tree is divided into three steps. First, take the data matrix as the root node. Second, use different decision tree algorithms to find the largest attribute as the criterion for branching. Common methods include Gini coefficient, and the entropy. Third, if the accuracy of the judgment result of the algorithm rule used in the second step does not meet the condition, then calculate the next branch attribute. Gini is an attribute selection index that uses binary division of attributes to build a decision tree. So each node has only two branches connected to child nodes. For example, CART decision tree uses this coefficient to select better data attributes to construct a complete decision tree. For second is random forest. Random forest was proposed by American statistician Leo Bremen in 2001. The principle is to combine multiple CART decision trees, add a present number of data attributes, and randomly select split points to build decision trees for training. The trees look similar to increase the final calculation results. It is known from the principle that the random forest has multiple decision tree combinations. This machine learning is called ensemble method, which can also be called ensemble or ensembled. It must meet the condition that each classifier is different and the accuracy is greater than 0.5. The overall machine learning algorithm integrates the prediction results of multiple weak learners to enhance accuracy. The integration method creates a set of learners for training data and votes based on the prediction results of each learner. So it is more stable and more accurate. There will be no deviation or overtraining. The operation steps of integrated learning are as follows. First, create multiple data sets. Second, construct multiple learners. Third, integrated learners voting. Here we talk about the third issue is SVM, Support Vector Machine, proposed by Konina, Korintz, and Vabnik in 1993. It is mainly for the classification of binary data, and the principle of minimum classification error rate is used for two-category segmentation. SVM uses the current data as training, selects several support vectors from the analyzed training data to present all the data, remove some extreme values and packs the selected SVM support vectors into a model. SVM is supervised learning classifier. It can be used to analyze the classification pattern in the data. The main purpose is to do classification and the regression analysis. Given a training data set, each data with black dots, white dots is given classification answer 0 and 1. Each data is a vector, and the length of the vector is 2. SVM can construct a classification model to classify all data into two categories. If new test data is input into the model later, it can also be automatically classified into 0 or 1 category by the model. For the third one, for the fourth one is extreme gradient boosting. Extreme gradient boosting refer to the XG boost proposed by the initiator Chang Ting-Yi in 2014. The gradient means that the XG boost model is developed in C++ of the gradient boosting machine. Boosting belongs to the overall learning classifier, which will reduce the accuracy of many classifications. The model trees are combined to become a highly accurate model, which will be continuously revised, and a new tree will be generated every time it is revised. XGBoost proposes the concept of the block, which sorts the data before training, then save it as a block structure and reuse the data in the structure in the subsequent process so that the module can be parallelized and reduce the training time. Here, this research is based on these tools, models, applications to develop. Our research process is mainly divided into 7 stages. The first stage needs to confirm the purpose. The second stage collects the organized data and sorts out data that are helpful to the forecast. The third stage is data pre-processing, and the collected data is submitted to feature engineering and formalization. The fourth stage is for visual design. The important attributes in the data set are presented and observed using visual methods such as drawing charts to help us clearly understand the characteristics and the correlations between attributes. The fifth stage is to establish the model and use different models to carry out compare and use GridSearch cross-comparison to find the most suitable machine learning model for this data set. The sixth stage evaluation model. After the model is established, use the decision tree model, confusion matches, and the classification report at the evaluation index of the machine learning model. Finally, the seventh stage represents the prediction results, which are explained in two parts below. Here is our training data. We have 23 columns. Each column has different meaning, and we have 1,520,000 data. This about 1,500,000 not fraud data, and the other part is 20,000 fraud data. So here we use the 22 columns, 22 different variables to train the model to predict fraud index. So here we see that fraud index, if it indicates 0, means no. If it indicates 1, means yes. Okay, so we have a lot of the test data is about 420,000 data. And here is our summation test. We have to submit the summation test to the system, and then we know the correct percentage. Here is the first one is our training data set, like this one. Here is the other training data. And this is 23 each columns, the meaning each variables. For example, we see that the most important will be, there will be some parts important, like the ETP MD means the transition type of the transaction, the organizer code from 0 to 10. If we see that the FLG dash 3DS MK, whether the transaction uses 3Ds, Y means yes, N means no. 3DS is a safe design for online card or cardless payment. And also here is the fraud index, whether the transaction has been stolen. Yes means 1, no means 0. Only the train file has a note. Okay, so the train file will note the fraud index. So here we can see a lot of columns here. And also we will introduce some columns later. Okay, there will be some possible fraudulent instructions, situations, like we go out the foreign transactions. We do the transaction outside in the foreign in the other countries. And the second one is online transactions without 3DS security. The third one is traditional way of flashing the magnetic strip of the credit card. And the fourth one is installment. The last one is those who have been frauded. Okay, so we use the model is XGBoost model. We also received the files is CSV model. So we use this as a common format for importing and exporting in the database. Also, we use the SN non-PH model and the sklearn model. And we use other packages like pandas, hierarchy package, matplotlib library, Seaborn suite. For the data pre-processing, we do the attribute relations with a heap map. So we see there are a lot of columns here. And this is here, this line is all the number 1. So we can see some different, they will have bigger number, like this 0.56, or like this is 0.65. And we try to see the relation between them. Here, we found the time is composed of hour, minute, and a second, like this one. So it's 17, 26, and 52. That means this one. So it's hour, minute, and the second. So we have to do some data pre-processing is to translate that and to do the data cleaning. For the second one is this is the oscillation time. Here we can do the Python code, try to figure it out. We divide it into 4. That's 0, 1, 2, and 3. So even in some different way that if the data is flooded, so we can try to find it out. Because sometimes we will think that is the flood is happened in which hour, maybe, I don't know. So we try to find it out. For the second one is also that we try to do that is local time. For the third one and the fourth one, we found that there will be different kinds of this. Like 2 and 8 is more happened more flooded situation. Here we see that if we do the account, this different account will have a different way to find it out. So we believe that there will be precedent or for flood, and there is a chance of being stolen again. So if your car is ever stolen, then your car will be stolen again. The chance is higher. For the traditional flushing, the sweeping field shows the status of empty value. So we need to fill in the empty value. And then we can try to use the decision tree. And then we can use the XGBoost to draw the decision tree. Okay, so in this paper, we see that some figure shows that first time drawing of the machine learning model decision tree with some blank data. And we use XGBoost model to fill in empty values and redraw machine learning model decision tree like this one. And also find that we compose the data set into 2. The first one will be 80% test set and 20% training set, and try to use the GridSearch Cross-validation method to adjust the best parameters. So we try to use the confusion matrix and the classification report to find it out. Here, the left side is the XGBoost model. The right side is a random forest model. We can see that if we use a random forest model, the correct percentage will be 99.09%. And this is the coefficient matrix. For the left side is XGBoost model, and the correct percentage will be 99.45%. Okay. So here we use this. There will be 420,000 records. We try to do and try to find the accuracy, and then use the whole data set to do the divide into 2 parts. The first part will be 80%, and the other will be 20% flood index. Try to find the accuracy. So we use the complete 1.42 million data for analysis, but due to the imbalance of the data, the training model will be misjudged, and the accuracy rate is only about 10%. Later, we observed the process of the field information, delete some fields, some columns and variables, and that are not very helpful for data prediction, and then merge some fields with high relevant to effectively reduce the misjudgments rate and use this result for training, and the accuracy rate begins to improve significantly. So that's our research is what we do in this paper. Thank you for your listening.